So I built this little program to simulate ecosystems. So what's happening on here is the red dots are predators and they're chasing down the blue dots, which are the prey. And the blue dots, they're also herbivores and they eat this grass that's on the map. And the gray ones are rocks. And the green ones are grass. And after they're eaten, they regenerate themselves after 40 frames. And on the tiles, you see numbers, which is the energy level of the animals. And when they have a lot of energy, I think the threshold I set is for the blue ones is like 13 or something. Once they have 13, then they'll reproduce. They'll clone themselves and split into two, sort of like bacteria, kind of like splits itself into two. And similarly, the predators will also do the same when they reach a certain threshold of energy. And the rocks are there because if without the rocks, the kind of the red ones will just eat all the blue ones. The red ones will immediately catch all the blue ones. They'll like multiply in number and then just wipe out the entire population of the blue ones. And then after that, the predators will starve as well. So that's why I put the rocks in, because it allows, see, right, like the red ones, they get stuck on the rocks. It makes them a little bit less efficient at catching the prey, which allows this kind of a balanced cycles of rise and fall of the populations. So if you were to see, I have a graph running over here. Whenever the predators got to a high number, the prey numbers really dip. So if I can pause the simulation for a bit, and then you can see if the highest that the predators get is like 15. And then for the prey, the highest they get is maybe 70. The lowest the preys get is like maybe 20, 25. The lowest the predators get is at like about 7. So I can unpause it. Whoa, whoa, this is not good. Okay, so right now we've wiped out all the, so the predators got really good at wiping out the prey, and now everyone's dead. So that's not what we want. That's why we needed the rocks. And it actually, so this kind of thing, it doesn't happen when I have like a huge map. When I increase the map size, let's say to twice the size, and then make the tiles a bit smaller. That's the beauty of hard coding these things, is you can just immediately change it and then run. Who needs a configuration UI, right, when you can just do that? And here. So now, okay, so now it's going to get a much more stable system happening. And by the way, I programmed all of this in just one day, believe it or not. And, you know, I've heard about the idea of vibe coding for a while now, and I never actually tried it because I didn't know what to build. But then I thought of this idea, which is something I always wanted to do, you know, since 10 years ago. This idea of an ecosystem simulation. I remember in high school, we learned about this like kind of pattern of rise and fall of predators and prey, kind of like this. When the predator goes really, population goes up, the prey population goes down. But then when the prey population goes down, the predators have nothing to eat and they starve. They starve and their population goes down. And then you kind of get this cycle where the predator and prey populations kind of like are going opposite directions. You can't really see that right now, but yeah, you can kind of see it. When the red is high, the blue is low, and then when the and vice versa, right? You can kind of see it happening. yeah, so I really wanted to see how this would play out. Okay, so now we are in danger of. So here, the blue got really low, the prey population got really low, almost got wiped out, and the predators became really high. They're on different axes, so the predator axis is on the left hand side. So as they got as high as 50, and then the prey population is on the right hand side. So they're in the 250 to 75 to 100 range. Um, but yeah, I built this all within 1 day, and it wouldn't have been possible without the power of vibe coding. Which, if you haven't heard of what vibe coding is, it's basically using ChatGPT or some other AI like Claude to like write your code for you. You just enter a prompt like build me a simulation involving like this and that, and then it'll just generate the code for you. And in this case, I chose to do it in Python and Pygame. And oh, this is really interesting. You see how everything got wiped out over here, and now they're kind of coming back and repopulating that space. So yeah, the entire code is probably like 400 lines of code. It's pretty simple, um, especially since it's a prototype. Everything is in one file, but still, like when I was using ChatGPT to generate it, it ran into the problem after like very shortly. It ran into a problem where it it wouldn't have enough tokens to be able to fit the entire code in the response anymore. And at that point, I just had to ask it to add or change things, um, but without just spitting out the big file, right? Just give me the part I need to edit in the file. So, for example, when I asked it to here, like instead of spawning, so earlier I had the rocks kind of spawn randomly all over the place. Um, so I wanted to do it in a more clumped manner using a technique called Perlin noise. And then so it was able to do that, and I just had to copy and paste that code into the specific places in my code. So you kind of have to know a little bit coding to know where exactly to insert it. Now, you may not have this problem if you're using some tool like Cursor, which can modify like multiple files at the same time. But Cursor kind of has those tools have a habit of like changing everything. So you can ask it to just change the rocks, but then it'll change all of your code when you do that, and it might introduce new bugs. So that's why I wasn't doing that. But it's still pretty cool to be able to build something like this in a single day. Um, yeah, and it's so hard. The hardest part was just balancing the predator and prey kind of mechanics so that they can have this like balanced. Ooh, this is a really beautiful graph now. Look at that. So I can pause the game and I can show you, um, kind of like stretch this out a little bit. Yeah, see how like when the predator numbers rise, the prey numbers drop, and vice versa, right? Beautiful. This code, it even generates, of course I had to ask it to do that, but it even generates a population log CSV file that um, I could output and do graphs in Excel, right? So for example, this graph is an example of, I think, yeah. So the green, which one is grass? So, okay, so the green one is predators population, and the red one, orange one is grass. So as you can see, the grass population and the predator population, they kind of like rise and fall at about the same time, right? So it's really interesting. Yeah, pretty much the predators can just go and chase down the prey, but they take like a couple of turns to eat and digest the food. And the prey, they move as fast as the predators unless they're on grass. So when they're on grass, they eat the grass and then they take a turn to digest the grass, which is why the predators are able to catch up to them. But yeah, and then as you can see, the rocks are they really mess things up for some of these predators that get stuck on the rocks. They just get stuck and they die of starvation, which keeps everything balanced.